All right, so in Trig, lesson 7.2 this is for the ambiguous case of the law of sines. This is when, I know in geometry, you guys go to prove two triangles are congruent, and you use side, 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 or side, angle, side, and they always tell you that angle, side, side's not a possibility. Well, it isn't, and this lesson is going to kind of explain to you the why it would not prove two triangles are congruent. All right, so here we go. So this first one's telling me to solve for the triangle ABC if side A, that means the side opposite from angle A then, is 17.9 centimeters. Side C, so that means opposite from angle C, would be 13.2 centimeters. And angle C here of 75 degrees and 30 minutes. And so to solve the triangle, that means we need to find all the missing sides and the missing angles. So when I'm looking at this is where we see we have an angle and we have two sides. We have two sides, but the angle's not between them. So therefore, that's not side angle side. See, side angle side, there would be an angle measure here. So instead, we're still going to have to use our law of sines. Now, mind you, I could end up with one triangle. I could end up with two different possible triangles with this given information, or I could end up with no triangle that's not even possible at all. All right, so let's kind of discuss this. So right now I know angle C for sure. So I'm going to have to start with the sine of angle C over side C, and then from there I could pick either angle A or B. It wouldn't matter which one, so I just went ahead and picked angle A, so therefore the sine of angle A over side of A. All right, I fill in those numbers. Now I'm going to do my cross multiply and divide. So you would multiply 17.9 times the sine of 75 degrees and 30 minutes, and then I have to divide that by 13.2. Now, after I'm done doing that, this is the decimal that I get. Now, at this point, I'm looking for the angle measure. So if you're ever looking for an angle measure, that's when you do the inverse of the trig function. So in this case, I would have to type in the inverse sine of 1.3128, and that would give me an error that it's not possible. Remember, the sine of an angle has to be between -1 and 1. It can't be greater than 1, okay, or can't be less than -1. All right, so no triangle exists such that this happens. Now this picture here would be a little bit better of a demonstration. This is actually drawn more to scale. So if this angle right here is actually 75 degrees and 30 minutes, and then I used ratio and proportions on the 17.9 centimeters, and then this is at 13.2 centimeters. You notice if I swing that red line in or out, this will never actually make a triangle because that red segment will actually never touch this other side. Now, some of you might think, well, bring that other side up. But see, if I bring it up, then it's no longer 75 degrees and 30 minutes. So therefore, this was no possible triangle. Okay, so again, we're solving the triangle, and here's the picture. So angle A given, side A, so it'd be opposite of angle A, and again, side B, I'd be opposite of angle B. Now, again, I have two sides, but the angle is not between them. Okay, if the angle was between them, that'd be side angle side. So instead, I have angle side side. I don't know. Am I going to have one triangle? Am I going to have two? Or am I going to have none? All right, so we start with the angle that we know. Now, we knew angle A, so I'm going to have sine of angle A over side of A. And then from there, it didn't matter if I had picked angle B or angle C. Actually, I'm going to take that back. Yes, it did matter. Because I know side B, that's why I want to start with the sine of B and angle B. Once I fill in my numbers, I go ahead and I cross multiply these two and I divide by 35.5. So again, it's 39.2 times the sine of 61.4 degrees divided by 35.5. Now I'm going to take the inverse sine of that answer, and that's going to be my first possible angle B. So notice I did that as B sub 1. That's the first possible angle B. So we put 75.8 degrees here. And the other angle B would be its supplement. So whatever angle you're starting with first off of this, the first one you start with, you must take that answer from 180 to get the other possible answer. Now, if angle B was 75.8 degrees and angle A is 61.4, well, then I can get this angle C. Then from there, I want to get the other angle C. So now if angle B was the 104.2 and angle A was the 61.4, so I'd add 61.4, 104.2, take it from 180, and there's the other possible angle C. So what's happening right now is I'm actually going to get two different possible triangles that would fit this scenario up here. So now what I'll do is I'm going to take this side C over the sine of angle C. equal to, and from the beginning, I want to use the original information given, so therefore then I'm going to use side A and the sine of angle A. Once I fill those in, I'm going to cross multiply and then divide. So 35.5 times the sine of 42.8 divided by the sine of 61.4. That would be side C1. Now, how long would the segment be for side C in triangle 2? Again, I know angle A and side A, so I know I'm going to have that ratio, and then I'm going to set that equal to the side C and the sine of this angle here. So I go ahead and write out my ratio, fill in my numbers. Again, cross multiply and divide. You multiply these two, divide by the sine of 61.4, and then there's the length of side 2 for that triangle. So this actually has two possible triangles with this given information. All right, solve this triangle. I'm given angle B and side A. So because I've got two sides, I have an angle, not between them. So this is my angle side, or side angle, however you want to say that. And the angle that I know is angle B and side B. So that's the ratio I want to start with. So I do know that I'm going to start with sine B and side B. And then from there, I know side A, so therefore I'm going to take that with the sine of A. All right, we cross multiply. I multiply these two. We divide by 25.4, and then I have to take the inverse sine. Now that will give me the first possible angle A. So again, that was 19.6 times sine of 68.7 divided by 25.4. Now from here, I have to take the inverse sine of that answer, and that would be the first angle A. So angle A is 46 degrees. Now remember I said that we're then going to take that from 180. So 180 minus 46 gives me the 134. So you always want to start with the first angle you find, take it from 180 to see if a second triangle is going to be possible. All right, now remember, angle B was 68 degrees, 68.7 degrees. So if I add that to the 46 degrees and take it from 180, that would be angle C for triangle 1. All right, now angle C for triangle 2. If I add 68.7 and 134, that's already more than 180. So this time I will not get a second possible triangle. Not possible. I'm only going to get one possible triangle this time. Now to get that angle C, so remember the angle on the side we know were these two. So therefore I'm going to be using the 25.4 and the sine of 68.7. And that's going to be equal to the ratio of side C that I don't know and the sine of angle C that I just found. So we fill those numbers in and we cross multiply and divide. So therefore I can multiply these two, divide by the sine of 46, and that's 24.8 for side C in the first triangle. All right, so now it says, without using the law of sines, explain why no triangle exists satisfying angle B to be 93 degrees, side B to be 42, and side C to be 48. So I'm going to ask you is that when you have a triangle with a 93-degree angle, what kind of triangle does that make it? Is it going to be acute? Will it be obtuse? Will it be a right triangle? See, if you have an angle B of 93 degrees, then that makes you going to have an obtuse triangle. If you have an obtuse triangle, then angle B has to be the biggest angle because it's greater than 90 degrees. Therefore, and here I go. So if I have these two here, say at 20 degrees, and I'm looking at the ends, they're pretty close together. And if I go out wider, then they're going to be further apart at the ends, okay, the ends of the pencil. If I keep going and keep going and keep going, see, the larger the angle, the larger the side opposite it. So when I have that 93-degree angle, that means side B had to be the largest side. But see, side C was my largest side. So there's no way angle B could have been 93 degrees. So again, this side C was the biggest, therefore angle C had to be the biggest in this case for those two, comparing the two angles. And since angle B was already 93 degrees, I can't have a triangle with two obtuse angles in it. That ends your notes for this. So anyway, you guys need to make sure when you have side angle that you make sure you use the law of sines, and you must consider, do you have two cases? You have to make that consideration in this. Thanks, guys. We'll see you later.